Hello, and welcome to the CAD Builder training series. This video features a quick start guide for new users who want to test CAD Builder's CNC capabilities, but it may also help as a refresher for veteran users. So you have created a design and dropped in some cabinets through either the design module or the bill of materials, and you would like to send it to your CNC for cutting. How do you go about doing so? CAD Builder must first know how to build your cabinets and what materials to build them from. So the first step is to make sure that you have set the appropriate design options. You do not need to select them all, but several are key to continuing to the next step. Construction method and cabinet material assignment will determine how the cabinet face frame, box, and parts are built. Drawer box construction, drawer box material assignment, and guides assignment are critical to getting the correct overall drawer box sizes and subsequent sub-elements. It is important for the materials used in the cabinet and drawer box material assignments to be properly defined, especially when dealing with the material's thickness. This parameter not only affects the cut list calculations, but also your CNC code coordinates. The grain parameter also has a large impact on how parts will be nested. We also recommend that you use the appropriate units and precision. Define these within the application settings found in the main menu. The recommended units for CNC related pages and for materials is inches and 0.0001. This way you could take measurements with your micrometer and plug these values directly within CAD Builder. After setting the necessary design options, move on to the cut list module. It is there that you will define the machine and tool sets you will use to cut your parts. Note that the software will ask you to review if you haven't set all of the options, but you may continue with the current selection. Begin defining your tools by accessing the tool library at the top left of your screen. The Tools submenu is where you define your tool bits and their properties. Tools are listed in the left-hand column. Clicking on one will show its properties on the right. CAD Builder provides you a set of default bits to start with, but you must make sure that this information matches your real-life tools. You may adapt an existing tool to your usage, copy an existing tool, or create a new tool and start from scratch. We will try the latter in this video. Click on Create Tool and select the new item from the list on the left. Begin defining it by naming it at the top of the center column. Edit shape is required for door structure routing, so we will leave that for a future video. Use the description section to document details about the tool bit that can come in useful in the future, such as the make and model used for reordering. You may also edit the image used for the tool's thumbnail. The Tools Properties sections defines general settings for your tool bit. Set the diameter to the maximum cutting diameter intended for the tool bit. Pass depth refers to the maximum thickness of material the bit will take in a single pass, as opposed to the maximum cutting depth, which is the maximum thickness it will cut in general, otherwise referred to as the cutting length. For example, let's say this tool will be used to cut 3/4 inch MDF. With a pass depth of 1/2 inch and a maximum cutting depth of 7/8, it will cut the material in at least 2 passes, but it won't be used to fully cut out material greater than 7/8. Extra cut depth refers to the cutout behavior where the tool bit is set slightly deeper than the material thickness, sacrificing some spoil board to ensure a clean cut on the underside of the sheet. The greater this value, the more the spoil board is marked, so we recommend keeping this value at a minimum, such as 1/64 of an inch. Suppose that the tool is used to route out a pocket of material, like a dado groove. Pockets are cut by having the bit cut strips out of the area, much like a lawnmower might cut grass. Step over refers to the amount of material shared between its strip to ensure material isn't bent out of the cutting path. The closer it gets to the tool bit's diameter, the exponentially more time it will take for the operations. It is generally recommended to make this 10% of the diameter to minimize cutting time while ensuring that no unwanted material is left over. Entry point refers to where the material plunge locations are placed by default. You may either choose in the middle of a part's edge or in the corner. You will then enable or disable tool bits for different types of tool paths in the right-hand column, starting with the cutout operation type. Cutout refers to the cuts that fully separate panels from the rest of the material. If you do not intend to use this tool for that purpose, then uncheck the box. Otherwise, activate the operation type by checking the on and off box to be on. The cutout parameters are then defined. Ramp in refers to having a tool gradually enter the material by ramping instead of a straight plunge. This is especially recommended for end mill tools. If you enable this, then define the distance over which the ramp is performed. 1/4 of an inch, 1/2 an inch, or an inch is usually recommended. You may activate the ramp out as well but by then the panel is usually fully cut out of the sheet, so it's most often unnecessary. This will make the tool just plunge out of the sheet. Cut direction refers to the orientation of the cuts. There are no hard rules for the conventional versus climb mill in question, but it is generally recommended to use conventional for most wood species. Arc corners takes cutout toolpaths and arcs them at the corners. The resulting panel ends up being the same, but it makes transitioning from one axis to another gentler on the CNC. Corner arcing is therefore generally recommended to be left on. Small part handling determines which parts get onion skinned and which are cut out directly. None makes it so that no parts get onion skinned. Onion skin makes it so that it only applies to small parts, and full sheet skin uses it for all parts big and small. Onion skin thickness determines the thickness of the final cutout pass that will remove the small parts from the rest of the sheet. If you choose onion skin, then you must tell CAD Builder which parts you should consider to be small. There are two thresholds that do this: small part area in square inches and small part minimum dimension. If a panel fails either of these thresholds, it will be a small part and it will get onion skinned. Feed rate reduction reduces the feed rate by a percentage for the final onion skin removal pass. And finally, cut out onion skin manually can be checked on if you plan on manually sanding away the final layer. This can be a favorable course of action if your sheet is overly populated with small parts, but generally you should leave this box off so that your CNC can take away the final layer as well. Drill refers to the operations where the tool bit is plunged into material and then plunged out to make holes. Enable or disable this toolpath for this bit. Its only parameter is depth compensation. This sends the bit deeper than the hole is trying to cut, to account for the shapes of some drill bits where their tip does not match the full hole diameter. So this compensation should be set to the length between a tool bit's tip and where it begins to have the full specified diameter. For example, this tool bit's depth compensation is the distance from this point to this point. Data operations, otherwise referred to as pockets, is when a tool ruts out an area of material. Enable or disable its box. Tracing, sharp corner, and door refer to door-specific CNCing. We will go through these in a future video, so you may leave this off for this exercise. Congratulations, you have just defined one of your tool bits. Repeat as necessary until you have at least one tool for cutout, one tool for dado, and one tool for drill operations before moving on. The next step is informing the software what positions these hold in your CNC's automatic tool changer. Even if you do not have an ATC built into the machine, the CNC identifies what blade it is holding by a given slot number, so it is important to match this within CAD Builder. Do this by going to the Toolset submenu. Click Create Toolset at the top left of this page. Select this new toolset and look to the right-hand area. The Tools to Add column shows a list of the tools available to be placed in the toolset. Do so with your created tools by selecting a tool and then clicking Add Selected Tool to Toolset. You will then see it appear in the middle column that shows the tool name, tool position number, diameter, and the enabled operation types. Once you have a couple of tools in your toolset, you can reorder them by clicking on the Move Tool Down or Move Tool Up. Make it so that the position number matches your CNC's tool index. You may also populate positions with empty tools by clicking on Add Blank Tool to Toolset. For example, what if I have my 3/8" compression in tool number 1, but the 3/8" downcut in position number 7 with no tools in between? I simply add enough blank tools and move the downcut to the appropriate position. Do not place the drill tool in the tool set if it is mounted on a separate gang drill unit. This will be set in the next step. Now that we have our tool set, we must define our machine. Close the Tools library and open the Machines library. You may adapt an existing machine or create a new one from scratch by clicking on the plus button. Select the machine on the left side to reveal its properties on the right. Name this new machine at the top. After naming the machine, check the box on for the default machine and CNC machine. The options sections will be settled by your chosen post-processor, so leave this temporarily alone. The post-processor section has a drop-down menu which you will use to select your CNC post-processor. This is responsible for converting CAD Builder's output into your machine's language. Check short file names on if your CNC has a small control screen with a limited amount of characters. Uncheck it for the full file name format. Check drill block on if your CNC has an attached drill bank. Then click on Edit to configure. Spacing tolerance allows for a small tolerance around holes, such that 2 or more holes can be drilled with the same bank plunge even if they slightly mismatch the standard 32mm spacing. Spindle speed max and plunge rate set the shared block rotation frequency and plunge velocity. The bottom left of the page shows a schema of the attachment. To its right are drop-down menus that allow you to match the drill block positions to the appropriate drill tools. Click on OK once this is done. The Z-Safe clearance sets the distance above the material where the CNC will keep the tool tip when rapid moving from one entry point to another. Plunge clearance, on the other hand, is the distance above the material that the CNC will rapid plunge to before beginning the plunge or ramp in earnest. Park position tells the CNC where to park after it has finished cutting a given program. It is best to set this such that the gantry ends up being off the table, giving you the space you need to change the sheet. Minimum maximum feeds and speeds set safety limits for these feed, plunge, and spindle rates. This will then be used against your feeds and speeds to ensure no data point has an extra or missing zero. Such an error can lead to a damaged tool, material, or CNC. Flip side squaring cut handles flipping of the sheet for panels that have operations on both material faces. Disable this for the moment, as the details of this behavior deserves to be explored in another training video. The final parameter sets the thumbnail to use for the CNC image. We are ready to move forward with the optimization now that our tools and machines are defined. Click on Configure and Optimize at the bottom left to get to the optimization menu. The top left area allows you to filter out parts made of certain materials. In this example, the solid maple represents the face frame parts of the cabinet, so I will uncheck it from this optimization. You may use the bottom left area to enable the use of remnants saved from previous optimizations. The middle column is responsible for choosing the machine and toolset to use. The Tools area shows the toolset and the tool bits that constitute it. If the name of any tool is written in red, it means that it has a feed or speed that violates the safety thresholds established by the machine. You can see the details by clicking on the warning icon. Feeds and speeds come in pairs between materials and tools, such that every tool can have the optimal parameters for every material. These are by default 0, so you must initialize this set of parameters. Do this by first closing the Validation Errors menu and then clicking on Feeds and Speeds. Select the model materials in the left column to reveal its assigned rates on the right. It is not necessary to define all tool material pairs, only the ones relevant to the current validation, which you may review by clicking on the Warnings button at the top center of the menu. For this optimization, I must set the feed, plunge, and spindle speeds for my cutout, dado, and drill tools. Repeat this for the rest of the materials that you intend to optimize. Click OK when finished with this menu. The tool's name should be written in black when all validations are satisfied. This only needs to be done once for new material tool pairs, so these settings will be saved for the next nesting as well. The strategy order sets the order in which the tool paths are to be executed. You may reorder these by clicking on the up or down arrows. The right column of the optimization menu deals with the nesting parameters. The quality parameter can be set to either best or good. Best uses 4 nesting algorithms and chooses the most optimal for each sheet, whereas good only uses 1. It is generally recommended to choose best. Part spacing is the distance between adjacent panels, not including the toolpaths. Set this to just above the intended cutout tool's diameter. In this case, instead of 0.375, I will use 0.38 to accommodate my 3/8" compression. This will avoid cutting one part in conventional and accidentally cutting the adjacent panel's edge in climb. Find remnants enables the detection and cutting of remnants from waste material. If enabled, a waste piece must overcome the remnant's width and height minimum thresholds in order to be considered a remnant. The trim section sets the distance between the sheet's edges and the edges of the nearest allowable panels, not including the toolpaths. Set these to somewhere around half of the cutout tool's diameter to allow for tolerances in sheet placement, sheet sizes, and human error. You may also use this to compensate for material sheets with damaged edges, keeping panels from being nested onto damaged areas. All of these settings are saved across optimizations, so you can set these once, and the next time you optimize, it will already be configured. When all the parts are set, click Optimize. CABIL will now nest all the chosen parts, generating the statistics, labels, simulation animations, and CNC code files. We will also be sent to the next module called Optimizer. It is made of 4 submodules: layouts, G-codes, toolpaths, and labels. Go to G-codes to download your CNC files to your downloads folder. If more than one file is downloaded, then they are compressed in a zip file, allowing you to copy a single file to the appropriate computer and unzip all folders on the spot. You may then feed these folders to your machine directly for execution. The files' names will contain information on what sheet and material is being cut. If you see flipped in the name, that means the material must be placed face side down. Go to Toolpaths to simulate your cuts within CAD Builder, or to verify or change orders and entry points. Go to Labels to check and print your labels. And finally, Layouts will give the job statistics, such as material efficiency and amounts of remnant detected, in addition to allowing you to keep track of and update your cuts. These functions will be covered in more detail in future videos. Thank you.